charge. This is your point P. And we want to calculate the electric potential at this point P inside the field of plus Q charge. Are you clear or not? This is the main point. Okay, we are going to calculate the potential at point P inside the field of plus Q charge. Okay.
Yes,
now
yes.
we have already know we can't calculate. Yeah, we can't calculate electric potential at a particular point individually. Okay, so we must choose a reference point, okay, with respect to which we are going to calculate the electric potential. Are you clear or not?
Yes, sir.
Yeah. Okay, we can choose the one another point is at infinity. Okay, and this infinity point, at this infinity point, your potential is 0. Okay, we are going to carry out, we are going to carrying a unit positive test charge from infinity to this point in such a way that your charge should not be accelerated. Okay, your charge should not be accelerated. What will happen if the charge is accelerated? If your charge accelerates, then we know it starts to generate electromagnetic waves, okay, which is not required here. So remember here, your charge should not be accelerated, okay, while transporting from infinity to the point P. We can take here the separation from positive charge Q to the point P is R. To the point P is R. Okay, this is the separation from plus Q charge to the point P. Okay, and the potential at point P is VA. Sorry, VP. You can take here.
Yes, sir.
Now, what is your definition of electric potential difference? We have already know.
Electric potential is a point at which work there is
exactly. What is the potential? Sorry, can you tell me at potential P is greater? Sorry, potential of charge Q is greater at point P or at point infinity? Can you tell me?
So
it is greater
potential
at
is
point
greater
P. Okay, because it is closer to the charge Q, so we can write here V at P. The potential difference we have already know. Your equation is delta V is equal to W from infinity to V. Sorry, not infinity to V. Infinity to point P.
That point against electric field.
Yeah, externally. Okay.
Yes, sir.
You can take here externally over charge Q. Remember here, when your charge is reached at point P, then what will happen? This plus Q charge start to apply an external force on the point P in away direction, because this is your also positive charge in nature, okay, which is a test charge. And it start to apply a force upon this charge particle in away direction. And this force is your electric force, or you can also say this is your conservative force. Are you clear or not?
Yes, sir.
Okay, but we are carrying this charge by applying some external effort, okay, in such a way that the charge should not be accelerated. And can you tell me what should be the condition in which the charge should not be accelerated? It is only and only one condition is possible here, in which F electric must be equal to the F of external. Am I right or not?
Yes, sir.
So we can say that our applied force is acting along this direction. Okay.
Yes,
this is your F external. And one second. And we can also say in equilibrium, your F of electric is equal to the minus of F of external, you can say. Are you understand or not?
Yes, sir.
Okay, but we have already know what is your potential difference. We have delta V is equal to the work done from infinity to A externally. Are you understand? External work. Okay, and over Q This is your equation number 1. Okay.
Yes, sir.
And now place what will happen if your charge is of 1 coulomb. When you put this 1 coulomb charge, then you can write here delta V. Delta V can be written as V at P minus V at infinite is equal to W of infinite to A externally. 1 second. W of infinite to A externally. Okay. Or
Yes,
we
yes.
can also write V at P is equal to W infinite to A external. This is your equation number 2. We have taken here V infinite is 0. Okay.
Okay, sir.
Are you clear till here?
Yes, sir.
And now, what is your value of W external? Can you tell me?
Value of W external.
Yeah, we have W of
Yeah.
infinite to A externally can be written as integration of minus from infinite to R Q into E dot dr. Are you clear or not?
Yes,
And
sir.
now in this equation, just Harsh, I want to ask you, what does represents this negative sign here? Remember that this negative sign represents that as we carrying this unit positive test charge from infinity to the point
infinity
P,
to point, right?
okay,
Yes,
we
sir.
are carrying this point charge from infinity to point P, okay?
Yes, against the electric field.
Yeah, your separation from plus Q charge is decreasing.
Yes, sir.
Are you clear or not?
Yes, sir.
When you are going from infinity to point P, then can you tell me your R is decreasing or increasing?
R is decreasing, sir.
Exactly. R is decreasing. Okay. Okay. So yes, this negative sign represents that this negative sign especially related to this dr. Are you understand or not?
Yes, sir.
But we are taking it outside from the integral. Okay. Just for our convenience here. Are you understand?
Yes, sir.
Okay. Good. So now we can put this value. You can take it your equation number 3, and we are going to put value of 3 in 1. We can not in 1, yeah, in 1. 1 second. We add externally. Just 1 second.
Yes, sir.
We can write here. Everything is okay, but
sir, it should be in 1.
No. You can correct it once again. Everything is okay, but I want to increase one more step. You can take here directly Vp minus V infinite.
Okay, so delta V.
We can write here Vp is equal to W infinite to A. Just 1 second.
Yes.
Before it, 1 second. Before it, increase one more step. Vp is equal to W, you can take here, this is your value of 0, infinite to A, W external over Q. This is your equation. Okay. Yeah. Okay. And now you can take here if Q is equal to 1 coulomb. Okay. Then this is your correct. Okay. Everything is correct, but I have taken one more step. Okay. Now put this value of work done from infinity to A into your equation number 1. When you put it, you get V at P is W infinite to A can be written as infinite to R Q E dr over Q. This Q is cancelled with Q. Okay.
Yes, sir.
We get V at P is equal to minus of infinite from minus of integration infinite to R E dot dr. Are you understand?
Yes, sir.
Okay. This is your equation of potential at point P. Or you can say this is your value of potential at point P while transporting a charge from infinity to this point P. Are you okay or not?
Yes, sir.
I think it is very, very clear. Okay.
Yes.
Note it down, please.
Sir, what's the heading, sir?
In the same heading, electric potential.
Okay,
After
okay.
yeah, after writing your definition, okay, you can
Yes, sir.
continue it from that from there. एक मिनट सुन.
Done, sir.
Okay. And now we have a question. Now, electric field in a region is E is equal to A over x cube I cap.
Sir, we did this, sir.
Sorry.
We did this question.
Hello.
Sir, we did this question.
Yeah. Calculate. Acha. Have you solved it?
Yeah, last class. You can check the pages, sir.
No issue.
Calculate potential in this region.
Okay. Another question, please. Calculate VA minus VB. This is your x-axis, and this one is your point B, and this is your point A. The angle of this electric field from the x-axis is 45 degree. Okay.
Okay.
And the separation between A to B, separation between A to B is 5 meter.
Okay.
And the magnitude of electric field is given as E is equal to 10 N over C, Newton per coulomb. Okay.
Yes,
And your question is VA minus VB. Calculate VA minus VB. Okay.
Okay, sir.
Can you solve it?
Sir, I'll try. Sir.
Yeah.
Like, why do we have given the angle, sir?
Yeah, exactly. Yeah,
Like,
angle
there is
is
no use
also
of
included.
angle.
Sorry?
There is no use of angle, sir. Is there?
We can use it.
But in the last equation, like there's no angle.
We have already no. You have already know. We have an equation which we have already studied here. VA minus VB
Minus VB
is equal to minus of E dot RBA.
RBA.
Do you remember or not?
Yes.
Do you remember or not?
Yes, I remember, sir.
Okay, but electric field and the displacement vector are operated with a dot product here. So we can also write minus of E R of BA. 1 second. R of BA can be written, just 1 second. RBA into cos theta. Can we write it?
Yes,
can we write it or not?
An angle, yes.
Okay. Or you can also
We
write
can,
E.
sir.
Yeah.
Yeah.
Value of E. What is the value of E? Value of E is
10 Newton. 10 Newton.
10. R of BA is 5. What is your cos theta? Cos theta is your 360 minus 45 degree.
45.
You understand?
Yes, sir. Yes.
Okay. Then.
Yes, sir. I'll
Once again, you get 10 into 5 into cos of 45 minus of cos 45, basically. And you get 10 into 5 into, what is your cos 45? 1 over root 2.
Cos 45?
Yeah.
1, sir. 1 by root 2.
1 by root 2. You can say 50 over root 2.
Sir?
Or you can also write 25 root 2. Yeah. Tell me.
Excuse me, sir. Sir, in the above equation, like 10 into 5 into cos into 360 minus 45, right?
Yeah.
Sir, we should minus it, right? Or just write 45?
Yeah, after converting it from cos 360 minus 45, you get again in the terms of cos function.
Okay.
Are you understand or not? Okay. This is your trigonometrical identities.
Yes, yes.
Have you mathematics in 12th or not?
No, sir, I have bio.
Oh, but don't worry. This is a trigonometrical identities in which if you will convert cos 360 minus 45, you get minus of cos. Sorry, you can take here not 45. You can take a theta in general term. you get again minus of first.
Minus. Okay.
Okay. Yeah. Now this is your in bold. Note it down.
Yes, sir. Done, sir.
All right. Next heading is electric potential due to a point charge. Electric potential due to a point charge. The process of derivation is exactly same as we have did in the previous case. Okay. Once again, we are going to take a positive positive charge, which is your source charge plus Q, and we are going to take, we are going to calculate electric potential at some particular point P here.
Triangle diagram, right?
Okay.
Yes.
Once again, we will consider a point at infinity. This is your infinity, at which V at infinity is 0. We are going to carrying a unit positive test charge from this infinity point to the point P. Okay.
Yes, sir.
After reaching at this position, we get two different forces. The first one is your F of electric, which is applied by the capital charge Q, or you can say this is your conservative force, F of electric, or you can say F of C. Okay.
Yes, sir.
And in the opposite direction, you get F of external. Separation between charge and the point P is again R. Are you clear or not?
Yes, sir.
Okay. We can choose here. We have a point, an infinitesimal point, which is your D and C. This is your dx. Are you clear? Now, what is the electric force on the charge? What will be the value of in equilibrium? We have already know. In equilibrium, F of external is equal to minus of F electric. Okay. This is the equation number 1. And now what is your electric force on charge This is your plus Q charge, and it is magnitude always be taken as 1. Okay. Charge
Yes.
of plus 1 coulomb due to capital Q. We have already know F of electric from the Coulomb's law. Sorry, from the equation of electric field, 1 over 4 pi epsilon naught Q over x square. This is your equation number 2. Are you understand?
Yes, sir.
Work done. Now, in next part, we are going to calculate the work done in carrying a charge from infinity to that point. Now, work done in carrying charge of 1 coulomb from infinity to point P. Okay.
Yes, sir.
W is equal to W of infinite to P. External is integration of F of external dot dx. Are you clear?
Yes, sir.
F of external dot dx.
DX.
And we have already know your F of external is equal to the minus of F electric. So you can put it here. This is your infinite to point P. Once again, we can take infinite to point P. And now F external is minus of F electric. Are you clear or not?
Yes, sir.
Dot dx. Once again, it is not clearly written here. I'm going to write here again. F electric, okay?
Yes.
Dot dx. In this case, your F electric dot dx, right?
Yes, sir.
If you expand this part, you get what is the direction of displacement and the F of external electric, both is same. So we
Same.
can write here, what is the value of F electric? The value of F electric is you have
F electric.
1 over 4 pi epsilon naught. We are going to take outside. Okay. Infinite of
Yes, sir.
Q over x square. Are you understand it or not? Don't
Yes,
worry.
sir.
I'm going to increase one more step. Infinite to P. Okay. Sorry, not P. Infinite to R here. This limit is R. Infinite to R. F electric is 1 over 4 pi epsilon naught Q over x squared dot dx. You can take Q over 4 pi epsilon naught integration of 1 over x square outside from the integration dot dx. Are you okay? Are you okay or
Yes,
not?
sir.
This is your W.
Yes, sir.
Note it down till here, then we will continue.
Okay. Done, sir.
Right. Here we have W is equal to Q over 4 pi epsilon naught integration of infinite to R 1 over x square dx. Okay. This is our last equation.
Yes, sir.
But now, can you tell me, can we integrate it directly or not?
We can.
No. Why? Because
Sir,
this function is not in the proper way. Okay. Or you can say this function is not in the form
1
of
by x square. Okay.
your formula of integration for such type of function is, if your function is x to the power n, then we can write here after integration x to the power n plus 1 over n plus 1. Okay. So first we are going to change this function into the standard form, and we get q over 4 pi epsilon naught integration of infinite to r x to the power minus 2 dx. Are you understand now? After transferring
Yes,
x
sir.
from denominator to numerator, you get x to the power minus 2. Okay. Now, what is your value of n in this part?
Yes, sir.
What is your value of n? Can you tell me?
Value of n.
What is your value of n? If you compare
Sir,
this,
x square, x. Sir, x square.
you get
Minus 2.
value of n is minus 2.
Minus 2.
Okay. So we can write here x to the power minus
Yes,
2 plus 1 over minus 2 plus 1. Okay. From infinite to
yes,
r,
sir.
you get q over 4 pi epsilon naught
Or 4 pi
x to the power
epsilon.
minus 1 over minus 1. 1 second.
Minus 1.
There is also minus 1 is okay moving with us. Yeah, this is your minus, this is your minus, this is your minus. Again, this minus and minus will be plus. You get W
Yes,
is equal to Q over 4 pi epsilon naught from infinite to R. After transferring x to the power minus 1, after changing, we get 1 over x from infinite to R. Now we can put here Q over 4 pi epsilon naught. Once you put 1 over at the position of x, first you put R and then infinite, and we will subtract it. Finally, you get W is equal to Q over 4 pi epsilon naught R. Note it down, please. This is your
yes, sir.
work done. Okay.
Final.
In carrying the charge
Yes.
from infinity to this point P, and remember that this work is the potential at that point.
Yes, sir.
This work is potential at that point. So we can write here V is equal to W is equal to 4 pi epsilon naught R. Okay.
Yes, sir.
Note it down, please. Is everything is clear or not?
Yes, sir, it is. So,
Yeah.
sir, as you know, next week I have exam, so I won't be able to do classes. Sir.
Okay. You are not available in the next week, right?
Yeah, next week, and then half of the next week. Like I'm not available 28th.
28. What? Which one day is on 28?
So 28th is Monday, I guess. 28th is Tuesday. So
You are not available on Tuesday, right?
Yes, sir.
Here is my calendar. "28 is Tuesday.
Okay, it's Tuesday.
When you are not available, on which day?
Sir, I'm not available from 22nd till 28th.
22nd is Wednesday.
Yeah.
Okay.
Like I won't be able to do next week, sir, because I have exams, so I have to prepare.
You can inform me if you are not available on my mobile number. This is my mobile number 752. Okay. 999
Yes, sir. Just
4440. Okay.
yes, sir.
You can place 91 as a country
Yes.
code.
So just now I'll note it now.
Okay, you have noted.
So one. Yeah, like I noted the equation, just your number one.
Have you noted it or not?
So noted, sir, noted.
Okay, can we move on?
Yes, you can.
Now, one more thing is important to know here. Your potential.
Sir, it was 999, sir.
Sorry. Yeah.
Can you repeat? Can you repeat a number?
752
752 999 444
0.
0, right?
Okay.
Yes, sir.
It is also, remember here, the potential of positive charge. Potential of positive charge is positive.
Yes.
And that of a negative charge is negative. Okay.
Okay.
And now from this equation, you can look at here. V is inversely proportional to the R. If you want to draw the diagram, sorry, if you want to draw the graph for this, then you can draw it like this. This is your graph, is like hyperbola. This axis is R and this one is the volt. This is your for plus positive charge. I mean, when your charge is positive. Okay.
Okay.
Or you can say when your potential is positive. Okay.
Okay.
And when your charge is positive, then potential is also positive. Okay. And now what will happen when your charge is negative? When the charge is negative, then potential also be negative.
That is negative.
This is your R, and now this is your minus of V. Okay.
Yes, sir.
This is your minus of V. This is the graph for it. Okay.
Yes.
Note it down, please. For Q is negative, or you can say V is negative. Have you noted it?
7 minutes, sir. I'm just adding the down. Done, sir.
Okay. Next one. Now the next heading is, what is the equation of potential when the system of charges are given? Okay. So please note it down.
Yes, sir.
For a system of an interacting point charges, your electric potential at a point is algebraic sum of potential due to individual charges. Due to individual charges. Okay.
Yes, sir.
Suppose that we have, this is the charge Q1, this is your charge Q2, and this one is your charge Qn. There is another point is P, where we want to calculate the potential due to all of these charges. So you can join first all of the charges from point P in this way. And now you can write here, this is your point P. Okay. This one is your R1, this one is your R2, and this one is your Rn. Then what will be your value here? Your potential of V1 due to charge Q1 is Q1
Yes.
over 4 pi. Sorry, Q is same, I think. One second. Yeah, n interacting point charges are given, and we can consider here the point charges are nearly same. Okay. So you can take just 1 second. Give me 1 minute. Required to see here. Yeah, you can write here V1 is equal to Q1 over 4 pi epsilon naught R1, and V2 is Q2 over 4 pi epsilon naught R2. Similarly, Vn is Qn. Okay, Qn over 4 pi epsilon naught Rn. Are you clear till here?
Yes, sir.
What is the total potential at P?
Total potential at P.
Total potential at P.
Q1.
So V is
Sir,
equal to
Q1.
V1
Gotcha. V1 plus V2 plus V3.
up to the Vn. Okay. When
Yes,
you
sir.
put the values of V1, V2, and V3, you get V is equal to Q1 over 4 pi epsilon naught R1, Q2 over 4 pi epsilon naught R2, plus dot 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 up to Qn over 4 pi epsilon naught Rn. This is your V is equal to 1 over 4 pi epsilon naught can be taken outside of this equation,
Yes,
and we get Q1 over R1, Q2 over R2 up to the Qn over Rn. Okay, and finally we can write V is equal to 1 over 4 pi epsilon naught in bracket Q, sorry, 1 second, summation of Qi to the Ri, where I is equal to 1 to n. Are you understand it or not?
yes, sir.
Note it down, please.
Yes, sir. Yes, sir.
One more second, please. One more
Yes,
second.
sir. Yes, yes.
When your charge is continuously distributed, okay? So
Yes,
you
sir.
can write for continuous charge distribution. When your charge is continuously distributed, you can write V is equal
Yes,
to 1 over 4 pi epsilon naught integration of dq over r. Now you can note it.
Done, sir.
Okay. And now we have a question on this. One second. I am choosing a question, a perfect question for this. Okay. Please write down one more thing in this, okay? Which is
Yes,
also
yes.
important for you. Write down potential in terms of position vector.
Potential in terms of position. Okay.
Vector. Okay. I mean, what is your equation of potential in terms of position vector? Okay. You can take it like this. This is your x-axis and this is your y-axis. This is your charge Q and we want to calculate at this point P, what is your potential. First of all, we should join all of the points from the origin. When you join this, you get this one. And for P, it is your this one. Similarly, from Q, this is your R of QP. Okay?
Yes,
This
sir.
is your R of Q and this is your R of P. Are you understand or not? And we
Yes, sir.
have R of QP can be written as RP minus RQ. Okay? So, then, you can say then, what is your V? V will be 1 over 4 pi epsilon naught Q over R of QP. And this QP also written as 1 over 4 pi epsilon naught Q, just 1 second, 4 pi epsilon naught Q over RP. RP can be written as RP minus RQ. Okay?
Yes, sir.
I understand or not? We have replaced this
Yes, sir.
RQP from RP minus RQ. Okay? Now, note it down, please.
Done, sir.
All right. Now, please note down a question. Three charges Q1 is equal to 1 microcoulomb. Q2 is minus of 2 microcoulomb. And Q3 is minus of 1 microcoulomb. Okay?
Yes, sir.
are placed at A 0, 0, 0, at B -1, 2, 3, and at C 2, -1, 1. Find potential at P, which is your -1, 2, -1. Okay.
Yes, sir.
Note it down, please.
Sir, I noted it down, sir.
Have you noted it?
Yes, sir.
Let's try to understand. Suppose that you have a position P here, okay, and 3 charges are given. This is your charge Q1. This one is of charge Q2.
Minus, so that's minus Q2, right?
Yeah, minus Q2 you can take. And this one is of charge minus Q3. Remember that this is not a exact picture of the question. Are you clear or not?
Yes, sir.
Because you
Yes,
can
yes.
look at here, this is given in the 3D format. Okay. And on
Yes,
a
sir.
plain 3D format is not possible to draw. Okay. So this is your imaginary generally, right?
Yes, sir.
When you draw Q1
Yes, sir.
to P and Q2 to P and Q3 is to P. Okay. Your coordinate of P is -1, 2, -1. Okay. The coordinate of Q1 you have already given here, and B is given, C is given. Okay. One second. You can take it QA, QB, QC. Take here QA, QB, and QC. Okay.
Yes, sir.
QA, QB, and QC. All right. Now your QA, QB, and this is your QC. All of the coordinates are given. QA is at 0, 0, 0, and this is your minus of 1, 2, 3, and for C it is 2, -1, 1. All right.
Yes, sir.
These are the total 3 points which are given here. These 3 points are given here. Okay. And now what is your separation? This is your R AP. Are you clear? This is your R BP. And this is your R CP. Are you clear or not?
Yes, sir.
Now, what is the value of potential at point P? Your VP is VA, VB, VC. Then your VP is 1 over 4 pi epsilon naught can be taken as QA over RAP plus QB over RBP plus QC over RCP. Are you understand?
Yes, sir.
Finally, we can write VP is equal to 1 over 4 pi epsilon naught QA. This is your QA over RAP can be written as RP minus RA. Okay.
Yes, sir.
Similarly, this is your QB and this is your RP minus RB. Okay. And this is your QC, RP minus RC. Are you understanding?
Yes, sir.
Good. What is your RP?
So total, right?
Yeah.
The total potential.
Yeah. You can write here VP is equal to 1 over 4 pi epsilon naught is 9 into 10 raised to the power 9.
No, ma'am, 9 days. Yes,
Okay.
sir.
What is your QA? QA is 1 microcoulomb. 1 microcoulomb in the sense 1 into 10 raised to the power minus 6 coulomb.
Yes, sir.
Over RP. RP can be taken as minus 1, 2 and minus 1 can be written as minus of
Minus
I cap
I cap.
plus 2j cap minus of k cap. Okay.
Yes, sir.
Minus. What is your RA? RA is totally 0. You can look at here.
Yes, sir.
Plus QB. QB is your minus of 1 microcoulomb.
Okay.
Sorry. Minus of 2 microcoulomb is given.
Yes.
Okay. Minus of 2 in the sense we can take negative sign. Two into 10 raised to the power minus 6 over what is your RP? RP is again same minus of I cap plus 2j cap minus of k cap minus what is your RB? RB is your
RB.
minus of I cap plus 2j plus 3k. Similarly, QC. QC is your minus 1 microcoulomb. This is also minus again. So it is your 1 into 10 raised to the power minus 6 over minus of, once again, your value of P is same, minus of I cap plus 2j cap minus of k cap. Okay.
Yes,
Minus.
sir.
What is your C? C is your 2I cap minus j cap minus k cap. Sorry, minus j cap plus k cap. Okay.
Yes, sir.
Note it down till here because we have no more space to write down.
Yes, sir.
It is a very big equation.
Yes, seems. Done, sir. Done.
Good. And can we remove it, some part?
Yes, sir. Yes. Okay.
Yeah, because it is impossible to write on the second page. Okay. Your equation is very big.
Yes, sir.
Have you noted this diagram also?
Yes, sir.
Okay. Now, what is your VP? Your VP is 9 into 10 raised to the power 9 into 10 raised to the power 9. And you can look in all of the equations, you have 10 raised to the power minus 6. We can take it also outside.
Yes, sir.
Now, in bracket, 1 over. Tell me, please. This is your same value, minus I cap plus of 2j plus of k cap in magnitude. Okay.
Yes, sir.
1 second, 1 second. No. In vector, still now here. In the next step, we will take it magnitude. Minus 2 over minus I 1 second. This is your minus, 1 second, I am writing here, minus of I cap plus 2j minus k. After multiplying this negative sign into this whole bracket, you get plus of I cap minus 2j cap minus 3k cap. Okay.
Yes, sir.
Similarly, the negative sign again here,
Yes.
1 over
minus of I cap
minus of I cap plus
plus 2j, 2j cap minus
minus
k
of
cap.
k minus
Sir,
2I,
plus. Okay, yeah, minus.
yeah,
Yeah. Plus j cap
plus j cap
minus k
minus
cap.
k cap. Okay,
Yes,
you can
sir.
take it in bracket. Next, 9 into 10 raised to the power 10 raised to the power 9 and 10 raised to the power minus 6 will be 10 raised to the power 3 now. Okay.
Yes, sir.
Now 1 minus of I cap plus 2j cap plus k cap minus 2 over minus of I cap. Look at here, minus I cap and plus I cap will cancel each other.
Cancel, yes, sir.
Okay. And 2j minus 2j again cancel.
Cancel.
Now minus k and minus 3k. It will be minus of 4k, I think.
Yes, sir.
So you can also write it like this: 0i, 0j minus 4k. Okay.
Yes, sir.
Minus 1 over minus I and minus 2i. It will be minus 3i.
Minus 3i.
And plus 2j and 1j. It is your plus 3j. Minus
Yes.
k and minus k will be minus of 2k. Okay.
Yes, sir.
This is your 9 into 10 raised to the power 3, 1 over minus of I cap, 2j cap, and 1k can be written as in the root of minus of 1 square plus 2 square plus 1 square. Okay.
Yes, sir.
Minus 2 over minus of 2 over in the bracket minus of 4 square minus 1 over minus of 3 is your minus 3 square plus of 3 square plus of minus 2 square. Okay, we have taken its magnitude, right?
Yes, sir.
This is your 9 into 10 raised to the power 3, 1 over 1 square. Minus of 1 square is 1.
1.
Plus 2 square is 4 plus 1. Minus 2 over minus of 4 square is 16.
16.
Minus 1, sorry, root of 16, right?
Yes,
1
sir.
over minus 3 square is 9.
9.
Plus
Root
9
yeah.
plus 4. Note it down.
Yes, sir. Sir, in that you could directly written at 4, right?
Sorry?
In the 2 by root 16, you can directly write it as 4, right?
Sorry, your voice is lagging.
No,
Tell
sir,
me please again.
In 2 by root 16, right?
Yeah, 2 by root 16. 1 second. Please note it down. Sorry?
No, you can directly write it as 4, right? Like, no need.
Yeah, we can write it. We can write it. Okay, but we will do it in the next step. Okay.
Okay, sir.
Yeah.
Done, sir.
Good. Now, this is your 9 into 10 raised to the power 3 in bracket 1 over root of 4, 1 and 1. It is your root of 6, right?
Root of 6.
1 over root 6 plus, sorry, minus,
2.
not plus.
Yeah.
2 over
Minus 2 by
4
4.
minus 9 and 9, 18, 18 and
18
4, 22.
22.
1 over root of 22. Okay.
Yes, sir.
You can consider this is your final answer.
Okay, so no need to do root 6.
No need to solve it more. Okay.
Okay, sir. Done, sir.
Good. Just give me a second. I am going to take one more question.
Of same size?
No, of different type.
Okay, sir.
Yeah, it is a very good question. Now, please note it down.
Yes, sir.
In this question, we have two parts. Okay. One of the part, okay, I will solve with you. And the second part is for you as a homework, right?
Okay, sir.
Yeah. We have a system of charge like this. This is your plus E. And this one is your plus of 4E. This is your minus of E. And this is your minus of 2E. Separation between these two is and 2 by 2. Separation is A.
Yes, sir.
Some another point at this position. Yeah, this is your A. And again, for this side, it is A. calculate the first one is electric potential at O and E. Second one is work done in carrying an electron from O to E. We have a point here. This point is located as E. Okay.
Okay.
And where is O?
In the
O is
middle?
at the center.
Yes, sir.
Okay. This is your O. And now we are going to draw it. In all of this, you have already know this part always be taken as if this is your A, this is your A. Then after calculation, you get this side is of A root 2.
A root 2.
This is also A
root 2.
A over root 2. A over root 2.
Root 2.
And
A by root.
Are you clear?
Yes, sir.
Then, what is the next point? How can you solve it? What is the solution? V at O is equal to, we can write 1 over 4 pi epsilon.
Epsilon 0.
Okay. The first one charge is taken here plus E.
Plus E.
So we can write here E over A over root 2 plus.
Yes.
Second
plus
charge
4E.
is 4E.
4E by A by root 2.
A by root 2 plus.
Plus.
Third one is minus E.
Minus E.
Okay. So minus E, if it is, then you can consider a minus of E over A by root 2.
Yes, sir.
And the fourth one is minus of 2.
Minus 2E A by root 2.
2E over A by root 2. Is it is clear or not?
Yes, sir, it is clear.
Any issue?
No, sir.
Good. You can take A by root 2 as a common.
Yes, sir, we can.
V naught 1 over 4 pi epsilon naught. You can take 1 over A by
root 2.
This is a E plus 4E minus E minus 2. Can you tell me what is the total value? E plus 4E,
5E.
E and E is cancelled. 4E minus 2 is
so 2E. 2E.
This is your 2E over 4 pi epsilon naught A over root 2. You can also write 1 over 4 pi epsilon naught 2 root 2E over A. This is your potential at O. Are you understand?
Yes, sir, yes.
Good.
It was like last question. Done, sir.
Now, in the second part, you can solve it such as this one. Okay.
Yes, sir.
Can you do it or not?
I'll try my best, sir.
Sure. Okay. And you can solve it easily, I think. And one more question I want to give you for homework, especially. And please note it down.
Okay, sir, I'll note it. Yes, sir.
Two charges, 3 into 10 raised to the power minus 8. Three into
10 raised to the power minus
8 coulomb and second one is minus of 2 into 10 raised to the power minus of 8 coulomb
Yes, sir.
are located at 15 centimeter apart.
Yes, sir.
Okay.
Yes, sir. So you're muted.
Yeah. At what point on the line joining the two charges is the electric, at 1 second, at what point on the line joining of the, at what point on the line joining of the two charges is the potential is 0. Okay.
Yes, sir.
All right. This is your question.
Yes, sir.
Yes. Note it down, please.
So done, sir.
Okay. So this question is especially for your homework.
Okay.
Okay. And you can send me on my WhatsApp. Okay.
Yeah, I'll
please
send you on
send-
the WhatsApp. And
Yeah, please send me hi on my number.
yes, I'll just send you 1 minute.
Okay. All of these questions are very good type of questions. Okay.
Yes, sir.
And please try to solve it. And now from the next class, we will try to focus. 1 second. Yeah. Okay. I got it.
Got it, sir?
Yeah.
Okay, sir. So I'll just message you when I'm free after my exam, sir.
Sorry.
Like I'll text you when when I have exam till what date, and then.
Yeah. All right. Okay. You can inform me when you
Yes,
are okay, not available, right?
Yes, sir.
Yeah.